Hello, this is Grinstar, and once again, I am messing with Reaper's JSFX or the in Bitwig here, YSFX. What I did last night was I created something that messes with the buffers and sort of created a reverser by accident. Trying to test and mess around with how the samples played around and stuff like that. So let me edit the script and show you what I did. So first, the top part is kind of similar. I just have a buffer length slider, and that's not really relevant, to be brutally honest. This actually started as I was thinking of how to play with grains and create a granular type of effect, which I found out is kind of harder than I thought. But the exercise is still here. So while in learning and how to do this, for every time the sample block here is called, that's when your audio comes in, and you get a chance to grab a sample section of the incoming audio source. So like milliseconds, if I'm not mistaken. So if you see these numbers going up right here, these go up by 1. And if you see how big the numbers are and how big they get and how fast they get, um, basically that's letting you know how many times the sample block is being called, because right here all I do is I have this, if a can play, and can play is just a variable that it turns off 1 or 0. See right here, 1 or 0. And that tells me can play. If it's 1, then start running up the counter. If it's 0, run down the counter. It goes from I think it's 2. So right here is where it flip-flops the bits, turns it off and on. So basically, if it goes over 5,000, then start counting down is what I need to do. And if it's under 2, start counting up. So this buffer IDL and IDR is the ID of the buffers, by the way. It goes up and down as actually, if you were watching this, it just goes up and down. Okay, this is a long road of trying to explain the craziness that is this. So every time that this block gets called, it either increments or decrements the buffer IDL number. And this is kind of important because basically what I do is I set the whatever the current sound sample is for that thing and put it in a buffer marked by that number. So I have, if you can think of it like a bucket of variables, I have 50,000 buckets that can hold these various samples of small little bits. And then it goes up and down and recording all this stuff and stores it in a little memory. And this is an array, and I'll after working with this, there's something in Bitwig that actually does this in a grid, and I'll show it. And it's sort of the same concepts, by the way. But at any rate, after all this is that basically if this turns off or if it's 0, then assign whatever that array is into the left-hand speaker. The SPL 0 is left hand, SPL 1 is right hand. And then test doesn't have anything. So basically you'll just hear the normal sound coming off the right hand, the right speaker. And it'll be really evident how this works. So basically, as you can see, this number goes up, and when it goes up, it's recording, and when it goes down, it's playing. It goes up, it's recording. It goes down, it's playing. It goes up, it's recording. It goes down, it's playing. So let me open up the piano sample here, and it takes a while to get in the sample. Okay, so what you're hearing is basically the me playing this thing and setting it backwards. So you can read SPL. This is the read, and this is the write SPL. Writing means that you're sending samples and information back into the pipeline or back out. So this is either writing stuff into my buffer and storing it for later, or it's writing out to the audio stream. and for later. So this just goes back and forth between 1 and 0, and if I play this one between 1 and 0 is whether or not you will hear the reverse or if you hear it playing. Um, and I don't think I can get both going at the same time of where it shows it. So kind of a cool I'm going to say it's a cool accident because like I said, um, I was learning how these buffers worked. To be, or not the buffers, but this SPL, SP1, and then the samples and how it worked and how I can use it to move around stuff because basically for it wasn't working. I was thinking that maybe I can use this buffer array to store samples and then use 1 to 10 samples and then have a random and have it play at random after that point. I can still do this, by the way. It's just these samples are very small. They make no noise. So therefore, it doesn't make any sense to kind of do it at that microscopic level that it's doing. You basically have to have a number of samples. I think it's like 40,000 or whatever the sample rate is, buffer size, 22,000 or 2,000, I mean. Um, Basically the sample rate is it dictates how many samples get played before you hear something, I think. And so basically put you can't do it in like 10 buffers. This is what I learned. You have to do it in quite a bit. So I made it 50,000 5,000 buffers. Or wait no 50,000 here. So what you're actually hearing is me capturing 50,000 samples in here and then playing back to 50,000 samples going from up and then down when it says I can play, it's going to play those 50,000 samples in there. If that, hopefully this is making sense. This is getting really complex in the amount of actual sampling and music theory. But this is kind of getting your way into understanding how you can manipulate sound, um, and the audio stream. So which gets you into basically the entryway into figuring out, okay, well everything's a sample, so how you manipulate that sample. This is just a number, um, as I found out. And it looks really weird. It's like 1 point, yeah, there we go, like that. It kind of looks like this a lot of the time. All of these variables are floating point numbers, which is kind of really interesting. To be brutally honest, it's weird to work with, but once you get used to it, it's fine. Because you can do null checks, and since everything defaults to 0, you don't have to worry about nulls and stuff like that. When you want to do like, is it default or does it have a value in it? This is sort of a pseudo um, loosely typed system. You don't have to declare variables. You can use them immediately. So it leads to is this variable initialized or is it not? Every variable as soon as it's created is initialized. As soon as it's checked, it always has 0. So that's actually really cool, and so you can play with that in here. So I can see what if my buffer contains for that index. This is the index of an array, by the way. Whether or not this contains information. Either that or it's just not going to play. So you can use this to create other effects and stuff like that. So in the kind of in the future, I can sit there and I can sample. I can go and sample up to, um, a block of sound, 50,000 samples, and then I can store that in a bigger buffer, and then use that buffer as a randomization type of playing around, and in real time kind of screw with the sound and create a sort of a weird wonky real time granulizer. Is basically what we're doing. So if you can imagine, Blias has a I own the Blias granulizer. So let me give an example of what I was trying to get to. So let me turn off the YSFX and let me get here. So this is kind of breaking up the sound and turning it into individual grains, which all these samples are. This one's a really good one because it has the reverse effect that I just showed off that's in the script. So it's basically doing the exact same thing that you saw what's in the script. It's sampling what's happening with the piano, and it's taking it and reversing it with the grains. Done. So you can basically do a lot of stuff with it. So, at any rate, that's what I was trying to do. And now I realize that I was gonna show something that I missed in the last video, by the way, for Shaper Box. This is what I get for thinking about stuff of what I'm gonna do today, and then going real time and not remembering. I was talking about the Shaper Box and about this audio stuff, but there's this little icon right here. When you click it, you have access to all kinds of stuff. Input, filter, which algorithm that you want to use, some detail, trigger shift, MIDI out. Hey, that's pretty cool. That's actually really cool if it sends it when it starts triggering. Huh. How would I test this? Let's see something yellow come through, right? Yeah, it doesn't look like it's sending MIDI out. Any rate, I missed it in the previous thing of working with Shaperbox 3, and I wanted to give an idea of that. Somebody asked about if it had an input filter, and indeed it does. Pretty cool. Okay, so there was one other thing I wanted to demonstrate, and that has to do with the grid. And the same kind of concept actually exists in this grid. Grid. Hold on a second. Let me add it. Okay, so in the grid, there's this array thing right here. And it kind of does the same thing as what I described. It has an array that stores samples. And basically this read pulse or write pulse is that on a pulse or a kind of up and down, or I think it's either a 1 or a 0, it'll trigger a read or a write of that table, and it will store those samples in the table in here, and then this gives the output. So you can do the same thing with this read and write phase. So let's use like probabilities here, and then another probabilities to do the read and the write, and let's mess around with it like here, and then let's do it here. So it's going to do 2 reads, 1 write, and then let's open this up, and nothing. I think this needs more of a pad or something, but technically this does the same thing as what my script did. Let me try for a more of a pad type of interface and pigments. Okay, I forgot about the trigger here. This gate thing also needs one that says, hey, how many times do I run the thing? So I got my pigments. It's got the loss on default patch, and you can barely hear it. but it's triggering it, and it's reading at that second, and it's writing at the second with the samples. Now, if we had something that should be like this all the way through, we should have more noise coming in. Wonder if a trigger would work better. Ooh. That sounded better. So let me try more triggers on here for the oh, because that's in the read phase. I got it. Wonder what happened if we give it a better phase. Phase. Actually, no, try phase in. Okay, so it's reading and writing kind of weird like that because it's not triggering long enough for it to be a valid read. Yeah, I know there's better ways of doing it. Any rate, it's the same concept. I need to mess with it more to get it to work, but I know it's the same thing as in this YSFX style of. Oh, it is not letting me click that. It's the same style of what we're doing here, but in the grid. To be able to read and write. And as you can hear, it's sort of grabbing stuff, and it basically you read in the samples and then or writing the samples and then you're reading the samples and it's triggering here. Why is this? All right, now it's working. Kind of weird. Any rate, kind of jumbled up type of thing, but I was working on it last night, and I thought it was actually really cool to create a reverser from scratch, and learning how the SPL input output works for the JSFX or the YSFX here in Bitwig, how they work and how they my grandson how they work overall. So hope you liked the video. And I will see you later.